As we look here to number 5, we have a rocket that has a weight of a 4.36 times 10 to the 4th newtons and has this engine that provides this upward force, this thrust of an 8.9 times 10 to the 5th newtons, and it's going to reach a speed of 860 meters per second. In this first part, we're asked to draw out a force diagram. So I drew the force of the thrust much larger than this weight down, the mg down. And it's an order of magnitude. So times 10 to the 4th, this is times 10 to the 5th. So this thrust should be much, much bigger. Now with this, we're being asked how long does this engine need to burn in order to reach a speed. So we're trying to figure out how long does it need to burn this time. So we know the change in momentum is equal to that force times that change in time. The force that the engine's going to provide, for how long does it need to do that in order to get the mass of the rocket to be going really fast, to change its velocity. That's what we're seeing here. So setting this up equationally, we're seeing that the change in time is going to equal to the mass of the rocket times the change in the velocity divided by this net force provided by the rocket. So that's why up here I've set up where we have the weight, that m times g that was given to us is a 4.36 times 10 to the 4th newtons. To get to mass, we divide by g, that 9.81, and we're going to get a value around 4.44 times 10 to the 3rd kilograms. So now we have the mass. So we have the mass for this time of the engine burning. We have the mass of the rocket. We know the final velocity of 860 meters per second. The initial velocity is 0. So now we just need our net force. Our net force, coming from our free body diagram, we have the thrust up minus mg down is going to equal to our net force. So thrust up minus mg, giving us this 8.9 times 10 to the 5th minus this 4.36 times 10 to the 4th, gets us about 8.46 times 10 to the 5th newtons. So now we have our net force, we have our mass, and we have our equation. So now we have everything we need in order to solve for this time. So the time is going to equal to this mass of this 4.44 times 10 to the 3rd kilograms, multiplied by that change in velocity, which is 0 to 860 meters per second. So the change is 860 divided by the net force of 8.46 times 10 to the 5th newtons. And this will give us around 4.51 seconds. So the time to burn this rocket engine would be about 4.5 seconds.